electric charges and fields. In our daily life, in nature, we are seeing some of the objects will be get attracted towards the another objects, or some of the objects get repelled with the another objects. Here the attraction whereas the repulsion is due to the charges which is present on that material or a conductor. Therefore, in nature there are two type of the charges. One is positive charge which is taken as proton, another one is the negative charge which is taken as electron. Basically, the charge idea was given by the scientist Thales, and for that charge the algebraic signs, that is the positive sign as well as the negative sign, was given by the scientist Benjamin Franklin. Here in case of the charges, the charge of an electron as well as the charge of an proton will be same, which is taken as plus or minus 1.6 into 10 to the power of minus 19 coulomb, whereas the mass of the electron will be of 9.1 into 10 to the power of minus 31 kg, and the mass of the proton will be of 1.67 into 10 to the power of minus 27 kg. Here, as we know that like charges repel each other. Like charges means positive, positive or negative, negative. Here, these are taken as the like charges in which the force between these two will be the repulsive force. Now, unlike charges attract each other. Unlike charges means positive, negative, they get attracted each other. In this attraction, whereas the repulsion, it does not depends on the magnitude of the charges, it depends on the sign of the charges. Is it positive or negative? That means it depends on the sign of the charges. The mass of the negative charge is greater than the mass of the positive charge. Therefore, here the charge value will be same for both negative as well as the positive, but the mass for the negative charge is more as compared to the mass of the positive charge. Next, here the charge what we are having, it is not having a particular direction, therefore charge is taken as the scalar quantity. In case of the charges, we are having some of the properties. The properties of the charges are, the main properties of the charges we are considering. The first one is nothing but the quantization of the charge. The second one, additive nature of charge, and third one, it is nothing but the conservation of charge. First one, which is nothing but the quantization of the charge. Here the charges which is present on the conductor in a system, the charges which is present on a conductor is the integral multiple of charges which is given by the equation Q is equal to NE, where N is equal to 1, 2, 3, etc. That means for a conductor, the charges which can be added or the charges which can be removed will be in terms of integral multiple of charges based on the equation of Q is equal to plus or minus NE. The second one, which is nothing but the additive nature of charge. Additive nature of charge means if you are considering a conductor, in that conductor certain number of charges is present, like Q1, Q2, Q3, like that certain number of charges will be present. The overall charge will be taken as the additive nature of charge. That means the total charge is equal to algebraic sum of the individual charges, which can be taken as the equation Q is equal to Q1 plus Q2 plus Q3, etc. Next, third one is the conservation of charge. In this conservation of the charge, in an isolated system, the charge is conserved. That means the charges will neither be increased nor be decreased, the charge remains same.